Morgan. What are we learning today?
Well, Jillian, today we are learning about the three laws of motion formulated by the genius mathematician Sir Isaac Newton in the late 1600s between the time frame of 1642 and 1727. Sir Isaac Newton came up with these laws to explain why things happen to move the way they do.
So we're going to start off with Newton's first law, which is an object at rest remains at rest, and an object in motion remains in motion at a constant speed and in a straight line unless acted upon by an unbalanced force.
This law is also known as the law of inertia. Inertia is the tendency of all objects to resist change on motion. The larger the mass, the more it resists change.
A bicycle laying on the ground will continue to stay like that until an unbalanced force, like a person lifting it, acts upon it, and the rolling bicycle will keep on rolling and will stop if an unbalanced force acts on it. Like the combination between the unbalanced friction on the ground and the air will cause the bike to slow down and eventually stop.
Due to a noise complaint, our location of filming has been changed because apparently we were too loud, but what do you think about that topic, Jillian?
I think we better continue with Newton's three laws.
What law are we on? I forgot.
The second law.
Are we still on the second law?
Yeah,
All right.
yeah.
Would you like to explain it?
Okay. Well, Newton's second law. The acceleration of an object depends on the mass of the object and the amount of force applied. This can be explained through the equation acceleration equals force divided by mass. So, in order to get an object moving, we must apply an unbalanced force. Well, Newton's second law states that a larger force will cause an object to accelerate faster than a smaller force would.
That's interesting. I think an example would be with Newton's second law of motion, if you're on a scooter and a friend pushes you gently, you will speed up slowly. But if she pushes you with a stronger force, you will speed up, and the larger the force, the faster the acceleration that will happen.
Mass plays a role because if you have a child and an adult on two different bikes and you apply the same force to push them, the child will speed up quicker because she has less mass. The skateboarders also have momentum, which is mass times velocity. It is actually possible to feel momentum. For instance, it is difficult to stop a moving object that has a lot of mass, like a bowling ball, or that is moving at a high velocity. For instance, like catching a baseball that is moving quickly, it would hurt really bad. So how does momentum affect Newton's second law?
Well, since the second law states that an unbalanced force causes acceleration, which is the change in velocity, then force also changes within momentum. Since Newton has three laws of motion, and I think we've covered the first one, right?
Mm-hmm.
And we just covered the second one, right?
Yes.
So I think it's time.
Acceleration equals force divided by mass.
True. So I think it's time for Newton's third law of motion?
I think so too. So Newton's third law states that force acts in an equal and opposing pairs. For instance,
when you jump, your feet are pushing down on the earth, but in return, the ground is pushing up against your feet.
3, 2, 1.
An object at rest will remain at rest unless acted upon by an unbalanced force. An object in motion continues in motion unless acted upon by an unbalanced force. Let's say you walking down the street cause you're going to the mall and something knocked you off your feet cause you ran into a wall. So you were acted on by an unbalanced force, which means you ran into the wall and it threw you off course. Oh, I get it now. An object at rest will remain at rest unless acted on by an unbalanced force. Yeah, often called the law of inertia. Yep. Bradley, come tell him about the second law. Come on.
Force equals mass times acceleration.
What?
So say I had to push a car to the gas station. It weighs 1,000 kilograms and rolls really slow.
What?
So it would take 50 newtons just for it to go.
For real? Oh, I get it. Acceleration is reduced when a force acts on a mass. The greater the mass of the object, the greater the amount of force needed to accelerate the object.
Law number 3.
According to Newton's third law, for every action there is an equal and opposite reaction, which means when you push an object with force, it pushes back with equal force, such as a rocket or a scooter. The rocket pushes down on the ground while the ground pushes the rocket up with equal force. And those are the 3 laws of motion. Yeah.
Morgan, what are we learning today?
Well, Jillian, today's lesson is about the 3 laws of motion, formulated by the genius and the what word?
Mathematician.
Oh.
Hello?
Oh. Thomas Edison, everyone! Newton is a genius, so he didn't just come up with one law.
He came up with
3. Well, our example. Thanks, Al. Newton's 3.
Some bloopers. Ready?
Yeah.
Nope, I have a better idea, Morgan.
What do I
Okay,
do?
put your feet up. Ready? Put your feet up.
I'm the clumsiest person in the world.
Ready? Have you got this? Okay, then you're
Yeah, good.
Go.
Smell it? No, point to it.
Disney cookie. Disney cookie.
Go get it.
You have to kind of push. Come on here. You want the cookie?
Oh, go ahead. Go ahead.
Daisy. Okay, I guess she doesn't want it.
She's like,
Come on.
come on. Now you want it? If I get off the skateboard, now you want it?
Yeah. Oh. Oh, she's getting scared. Go.